I have a,
Let's go, anyone?
I have like a C1.
You have a what?
I have a C1. I even have A or B.
I think that might be
Or
right. Very first one says, study the pattern shown in the table. What is the value of S when R equals 10? Okay? And so we're trying to find a pattern here, right? And the problem with this is, if you look at this from 7 to 11, how much did it go up by?
4.
4, but then from 11 to 23 it went up by
12.
12, and then from 23 to 43 it went up by 20, and then from 43 to 71 it went up by 28.
Oh, I get it.
Okay? And so those aren't all going up by the same amount. Okay? Now we just went through this. What we have to do now is look at the next one. Okay? How much did it go up by from 4 to 12? 8. How much did it go up by from 12 to 20? 8. And how much did it go up by from 20 to 28? 8. So that means that this is what kind of a function? It's not linear. If the first ones were the same, it would be linear, right? Since the second one is the same, that means it's quadratic. So it's got a squared in there. Okay? Because it's going up by the same amount when you look at the second set of differences. So, if I squared 0, what would I get? 0. And 0 plus what makes 7? 7. If I squared 2, what would I get? 4. And 4 plus what makes 11? 7. If I squared 4, what would I get? 16. And 16 plus what is 23? 7. So my formula, my pattern here is x squared plus 7. Okay? Hold on a second. And so that means that if I plug in 10, 10 squared is 100 plus 7 makes 107. Okay, Francis?
How do you know that it has to be squared?
Because when we looked at the first set of differences, they weren't the same. And then when we looked at the second set of differences, they were. And since the second set of differences were the same, that means it must be something squared. If the third set of differences were the same, then it would be something cubed, which would be really nasty. Yes?
I got 102.
You got 102? How'd you get that?
I don't know.
Okay, well what you should have done is squared the 10, which is 100, and then plus 7 makes 107. Okay? All right. So now if we take a look at the next one, this one, the next one says, Julie's grandfather gives her $1 every day. Now we talked about that also. Remember we did that little game in here? And I said you could have $100 every day for a month, or you could start with a penny and then double it the next day, and then the next day, and the next day, and the next day, right? So we worked through this one also. Each day after that, he gave her twice as many dollars as he had on the previous day. Let F of n represent the number of dollars Julie's grandfather gave her on day n. And the question is, how much will Julie have? Oh, first one is which function models the situation. So we have to figure this out here. We're going to make a little table. So on the first day, how many dollars does he give her? 1. On the second day, how many does he give her? 2. On the third day, how many? 4. And on the fourth day, 8. Okay? So the question is again, is this going up by the same amount each time? This one went up by 1. This one went up by 2. This one went up by 4. So it is not linear. So that one is out. Okay? So now we can just kind of guess and check with one of these things right here. If I plugged in 1 right here, 1 minus 1 would be 0, and 0 squared is 0. So this would be like saying on the first day she got no money, which is not the case. So that one's out. So it's either this one or this one. Okay? So if I plug in 1 here for n, 1 minus 1 is 0, and 2 to the 0 is 1. Okay, so that fits with this stuff right here. and so my answer is A.
Okay, you did your C, so why would you?
Okay, all right, good idea, let's check C. So if I put in 1 right there for n, 1 plus 1 is 2, and 2 squared is 4. Did she get $4 on the first day?
Yeah.
No, so that one's out
I put
also.
C, I was wrong.
Okay, so it's supposed to be A. All right, then it says, how much will Julie have after 12 days? Well, you could do the 12 days and then add up all the numbers, and that would give you your answer. But it's easier now that we know this is the equation to plug in 12 for n. Okay? So the formula says take the number of days and subtract 1. Well, 12 minus 1 is 11. And what's 2 to the 11th power? Not, you did 11 to the second power. No, 2 to the 11th power. Somebody tell me what you get from that.
Okay, hold on.
Okay. It'll be a big number.
2048.
2,048. So after 12 days, she's got $2,048. Which is what hopefully you remember happened when we did this together. We started at a penny. After a month, we had like $1 million or something.
Yeah, it was amazing.
It was truly
Like
amazing.
so much in the day here.
That's incorrect. All right. Mr. Madison gave his student this pattern of white tiles. So we're only looking at the white tiles. And once again, guess what? We have to come up with a pattern, an equation. Okay? So in day 1, how many white tiles were there? 8. In day 2 there are what? 12. Day 3 there are
16.
and then 20. Okay, so what is this going up by each time? 4. And so since it's going up by 4 each time, that means that this one will be linear, okay? And that's what all of these are, so those are our choices, okay? So if I went 4 times 1, I would get 4. What do I have to add to that to get 8? 4. If I went 4 times 2, I would get 8. What do I have to add to get 12? 4. If I went 4 times 3, I would get 12. What do I have to add to that to get 16? 4. So my pattern is 4 times the number and then add 4 onto it.
I've got C on all of them so far.
Okay. Okay? We good with that one? You so's. All right, next one. Now we're going to draw a little picture. Okay, this one says a cup is 5.2 centimeters tall. So here's my cup. And it's 5.2 centimeters tall. Okay? And then it has a 0.8 centimeter lip. So this little thing at the top is 0.8 centimeters, okay? So now we're going to start stacking up some cups. Since the lip is 0.8 centimeters tall, how high does my stack go up every time I stack a new cup? 0.8 centimeters, right? So basically what I've got going is I'm starting with 5.2, and then I'm adding on 0.8 each time, right? But this is a little bit tricky because, how's the best way to explain this? If I said 5.2 plus 0.8x, I would be wrong. Why? Because what? No, I'm okay with that. I guess what I'm saying is, if I have one cup in my stack, how tall will it be? From this picture over here. 5.2 centimeters tall, right? But if I plug a 1 in here, what answer do I get? I would get 5.2 plus 0.8, which means my stack would be 6. Okay, so there's two ways that you can do it. One way you can do it is you can say, okay, let's not include the lip. So if I take the first cup and I take away its lip, what's 5.2 minus 0.8? I don't know. What's 5.2 take away 0.8?
4.6.
4.4. Okay, so really my formula is 4.4 plus 0.8x. Okay, so that's what actually goes right here. So if I don't include the lip of the first cup, my stack is 4.4 tall, and then I'm going to add 0.8 of a centimeter each time I have a cup. So if I have one cup, I add just 0.8 onto it and get 5.2. If I have two cups, I need to add another one on there, and will give me 6 and so forth, okay? So now we have to use that to figure out how many cups are in a stack that is 34 centimeters high. So if I have 34 centimeters of cups, I have to subtract the body of the first cup, right? And I want to figure out the lips. So how much is the body of the first cup? 4.4, right? Because I'm not including the lip yet. So 34 minus 4.4 is 29.6. And that 29.6 centimeters that's left is all cup lips. But you didn't know that cups have lips. You know, chickens have lips too. So how many cup lips, each 0.8 centimeters tall, make up 29.6 centimeters total? How do you figure that out? Divide. So if I take my 29.6 and divide it by 0.8,
37.
then you get 36?
Yeah, it says it came out on mine.
That says 4.8x.
Yeah, mine came out as 37.
So close,
37.
close enough, 36, right? Okay. I don't know why that went sideways on us there a little bit. Okay, got that?
Yeah.
All right, now let's do some babysitting.
I like to babysit.
Okay, it says, house sitting, not babysitting. Okay, during the month of August, Jamie, bless you, Jamie will be house sitting for her wealthy neighbor, Mrs. Gates. Do you get it?
Mrs. Gates.
Who's Mrs. Gates? Bill Gates' wife. Mrs. Gates offers Jamie 2 different salary plans. Plan 1 is $100 a day for the 31 days in August. $100 a day. Plan 2 is $1 for August 1st, $2 for August 2nd, 4, and so forth, doubling each time. Okay? And so this is that same little equation that we had before. So write functions that model the amount of money Michelle will earn each day on plan 1 and plan 2. Well, plan 1 is easy because she gets $100 every day, right? So it would just be 100. Well, but we want to know times each day, so 100 each. Okay? So however many days you're working, you can just plug that in there for D, and I'll tell you how much money you've got so far. Okay? How about for plan 2? We already did this one. Do you remember the answer? What was it? It was 2 to the n minus 1. Because on the first day, if you plug in 1, 1 minus 1 is 0, and 2 to the 0 is 1, so she'd get $1 on the first day. Then if you plug in 2, 2 minus 1 is 1, 2 to the first is 2, so she'd get $2 on the second day, so then I'll tell you how much she gets in each situation every day. Okay? Okay, B, state an appropriate domain for each of the models. The domain means, we talk about this as the X values that you could plug in, okay? So if you're talking about the days of August, what's the lowest number that you could plug in? What's the lowest number, what's the fewest number of days she could take care of the house? The fewest number, if she was a slacker. One, you can go 0, I think, yeah. I mean, if you wanted to just totally blow it off and get fired, you could just do, you could be like, yeah, whatever, I didn't go over there one at the same time. What's the most number of days that you could go over there and check on her house and get the mail and water plants? 31. So the domain of this function, the numbers that you could plug in that would make sense, would be from 0 to 31. Okay? All right, which plan should Michelle choose to maximize her earnings? We did this together so you already know the answer, but how do you explain it mathematically? How much would she make if she went in there every day in August? 3,100. So plan 1 would be a total of $3,100. My pen is not.
Can you read?
No, it's because I'm writing on a PDF and it doesn't do that very well.
Wait, when is
All right, I'll go for it. You should know, you shouldn't have to read it, you should know because you said it and you understand the problem, you should know. $100 a day for 31 days would be $3,100. Okay? How would you use the formula that we came up with for plan 2 to justify why you should do that one instead of plan 1?
Well, 31's the end.
Okay, so 31 is going to be our n. So in plan 2, if I take and I plug in 31, to figure out how much money I will get on that day,
Holy crap.
yeah, that, you just justified it, okay? 31 is our n, so I'm going to go 31, 2 to the 31 minus 1 power. So that's going to be up 2 to the 30th.
And it's 1073741
Okay, do that one more time because my pen is really slow.
107
Hold on, slow down. I got to write really slowly or it freaks out. 107.
374
Okay.
1824. Wait, what?
Very big number.
I go with plan 2.
You're going to go with plan 2.
Yep. Amen.
1832. Thank you.
1824.
What if you're just a stupid kid like me and don't know the difference and wouldn't want to
Okay,
figure it out?
so that's the way that you could justify it. Just plug 31 into each of the formulas, and you're obviously going to get way more money from plan 2 than you would from plan 1. Okay, which is why that old Melinda Gates set it up that way. She wanted to see if you were smart or not. Melinda. Melinda. Okay, we got that one?
Got it.
Okay. All right, so that whole first section obviously was on functions, equations, and tables, and being able to take information and use it to come up with an answer for a future problem or write a function or something like that, okay? All right, now we're moving on to inequalities and things like that. So let's take a look at this one. Yes? The backside? Is it out of order or something? This is my next page.
This is the next page.
Really?
Just follow along with me, just find this page. Okay?
No one.
All right? Okay, so number 1 says, a classroom holds 36 desks. There are 15 desks occupied in the classroom already. Which inequality can be solved to show all the number of students S that can still have a desk in the classroom? So we just need to put an inequality symbol in there. So 15 plus S, so the 15, oh, they're occupied already. So there's
Less than or equal to.
less than or equal to, okay. As the total number of students in there, for everyone to have a desk has to be less than or equal to 36, okay? All right, number 2, the charges of $3 plus $5.50 per game downloaded. The GameBank.com charges an annual fee of $15 plus $2.50 per game. For how many game downloads will the cost be the same at both? So there's something missing here. This is supposed to be a different thing. So they charge $3 plus $5.50 a game. They charge $15 plus $2.50 a game. Okay, so we have to figure out when they would be the same. So the equation that you would write for this would be $3 plus $5.50 a game, right? So what letter do you want to use for our variable here?
X.
X. So that would be $3 plus 5.5 X. And what they want us to do is figure out when will that be equal to, what equation would I write for the game bank? 15, because that's what they charge, plus what? Plus 2.5x. Okay, excellent. Get it? Excellent. Okay, how do I solve that equation? Okay, but they're on opposite sides, so I would subtract, bring them together. So I'm going to go minus 2.5 from here. And minus 2.5 from here. But it's not 3 plus 3, it's 3 plus 3x, right? No, because I've already got all my x's on the left. So what I want to do now is I want to get all my numbers on the right. So how do I do that? Minus 3 from both sides. So if I subtract 3 from both sides, then that means that 3x equals what? 12. And now what do I do to solve that for x? Divide by 3, so x equals 4. Okay? So the answer to the question is fill in the blank, giving the correct number of games and the cost. 4 games. And on either website, how much would that cost? If you plug 4 into here, what's 4 times 550? 22. Plus the $3 to join means that will cost you $25. And you, okay, that is close. And you can check if you wanted to make sure that that's equal to this side over here. If I plug 4 into there, 2.5 times 4 is 10, and 10 plus 15 is also 25. And so that's what we're looking for. Where would the prices be the same? Okay? All right, you got that one? Okay, same deal then with the next one. Now we're hiring a plumber. Okay. And this one says 2 plumbing companies charge different rates for their service. Clyde's company charges $75 plus $45 an hour. We Unclog It Plumbers charges $100 plus $40 after that. For how many hours of plumbing work would Clyde's be less expensive than We Unclog It? So what's the equation for Clyde's? What's the equation for Clyde's? 75 plus 45x. And right, we want to see when that's going to be equal to the other one. What's my equation for the other one? Okay, 100 plus 40x. So same thing as the other one. How do I solve this equation? Subtract 40x from both sides, so that's going to give me 75 plus, what's 45x's take away 40x's? 5x equals 100. Okay, now what do I do? 100 subtract 75, which is what? 25. So 5x equals 25. So, right, if I divide both sides by 5, then that means after 5 hours they would be equal, okay? But this one they don't want us to figure out when they're equal, they want to figure out when will Clyde's be less. So is Clyde's going to be less for less than 5 hours or more than 5 hours? Less than, because he charges less just to show up, right? So it would be anytime x is less than or equal to 5 hours. All right? So same kind of thing we were doing before, but now we're coming up with inequalities to answer these instead of equations, but that's not a big deal. Okay, is this our last page?
Yeah.
Okay, so we'll finish this and then we'll call it a day, and then tomorrow we'll take a look at the packet that I gave you yesterday. Okay? Okay, at Seattle's Best Coffee, an employee has 1 cup of 85% milk and another cup of 60% milk. She wants to make 1 cup of 70% milk. How much of the 85% milk and 60% milk should she mix together to make the 70% milk?
I did just 10 plus 60.
You did what?
10 plus 60.
10 plus 60. I don't really get it. You went half and half. But if you go half and half, then your answer is going to be right in between 60 and 85, which is 72.5. So it's close, but not quite. Okay. Okay, this is kind of a tricky one. So I'm going to call the amount of milk. First, I guess I have to figure out the amount of milk I'm going to add of the first one. We're going to call that what? A, okay. And that's 60% milk, so I change that to decimal, so that's 0.6A. Okay, plus, what do you want to call the amount of milk? What?
Q.
Q. Okay, that's
Nobody likes Q or uses it. I like Q.
I'm really not happy with the board. Okay, and all together that's going to have to equal what?
70%.
0.7 what?
0.7
But times what? But we're not just putting A in there, we're also putting Q in there. So the total that I'm going to have left is A and Q, A plus Q. Oh my gosh. So you want to take the 60% and the 85% and make it so it adds up to 70% of the whole thing. Okay? Does that make sense?
Yes.
Kind of? So what do you do with the parentheses? Oh, you guys know how to do this. Come on now. What do you do?
You put 0.7 plus 0.7 Q.
Right, I have to distribute the 0.7 between 0.6A plus 0.85 Q. You know what? I have to go 0.6A plus 0.85 Q and then distribute the 0.7, right? Like that?
Yeah.
Okay, now what? Okay, let's get them together. So I'm going to go minus 0.6A from both sides. So those cancel. So 0.85Q equals, what's 0.7A minus 0.6A? 0.1A. Plus 0.7Q. Now that I have all the A's on the right, I have to subtract the 0.7Q from both sides to get them all on the left. What's 0.85Q minus 0.7Q? Nice, 0.15Q. And those cancel. And now I need to either divide by 0.15 or divide by 0.1. Which one would you like to do? 0.1 because it's smaller. So what is 0.15 divided by 0.1? 1.5. Okay, so the answer is not 50-50, but I have to put in 1.5 times as much of the other milk as I did the first one. Okay, so the A milk has to equal 1.5 times the Q milk. Okay, all right, let's do that last one. And then, like I said, we will call it a day. All right, so the last one says Radio Shack makes a $100 profit on every DVD player it sells and a $60 profit on every CD player it sells. The store manager wants to make a profit of at least $600 a day selling DVD players and CD players. Okay, so this says write a linear inequality, determine the number of DVD players X. So our x-axis is actually going to be DVD players. And CD players Y that the owner needs to sell to meet his goal. Well, it's an easy equation, right?
Yeah.
Because you get 100 for every DVD player, so how much do you get total? 100x plus, how much do you get for every CD player? 60, so we're going to go plus 60. Y, and he wants that to be at least or greater than equal to what? 600. Okay? So 100x plus 600y equals, or is greater than or equal to 600. All right? So now I need to graph that. So we can do that other cheaty way that we did before. If I cover up the y's, where does it cross the x-axis? 6, because 600 divided by 100 is 6. So I'm going to put it out at 1, 2, 3, 4, 5, 6. And then if I go the other way and cover up the x's, where does it cross the y-axis? 10, because 600 divided by 60 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now I'm going to connect those dots. Do I connect it with a solid line or a dotted line?
Solid.
Why solid? Why?
Because it's equal to.
Right, because it's greater than or equal to. Okay, so I'm going to connect that with a solid line. Okay, and then I need to shade that. So it's an inequality. Do I shade above or below? Above, because it's greater than. So any of the answers in there would work. Okay? All right, so it says list 3 possible combinations of DVD players and CD players that the owner could sell to meet his goal. Now, if you want to be funny with this, you could get all fancy and pick some points up there, right? But if they want to make at least $600, couldn't you say like 1,000 DVD players and 1,000 CD players? Isn't that going to work? Yeah, because you're going to make way more than $600 then, right? How about if you went 10,000 DVD players and 10,000 CD players? Is that going to work? Yeah. How about 100,000 DVD players?
They don't have that much.
Didn't say that. What they really want you to do is they want you to go through and pick some random points from this graph up here from the shaded area that you did, and then write down those. So, you know, this many, this many, this many, but, you know. Okay, we got her?
Yeah. What's your name?
Sure, make sure your name's on there. Awesome.